Hello. Hey, welcome back. This is 2.1 in college algebra, and today we're going to be working with complex numbers. Okay, so if you ever wondered what the square root of -1 was, well, congratulations, you're going to find out today, right? Okay, so first we need this thing called the imaginary unit. And we define it, and it'll be this letter I, the imaginary unit, equals the square root of -1. The square of this thing, then, if you take I and you square it, you're going to end up with -1. Okay. Okay. Now we can define the complex number. So the complex number is basically just a real number plus this imaginary part. Okay. All the numbers that you dealt with, all the real numbers are actually complex numbers. It's just that the imaginary part is 0. Okay, so it just gives us an extra dimension to work with. And the name imaginary, if you read about the history of it, it's kind of unfortunate. Like when it first came out, a lot of people thought it was just a crazy idea, I guess. But it turns out to be extremely important. Okay, so anyways, there's that. Complex number, some number A plus this other imaginary thing, right? So the A is called the real part. The B is the imaginary part. And whenever we deal with complex numbers, we want to write them in this form. And this form, A plus BI, is called the standard form. Okay. One thing about equality, so one small, minute detail, which probably goes without saying, if you have something like A plus BI equaling C plus DI, you can equate the coefficients on either side. In other words, A will equal C and B equals D. The real part is equal to the real part on the left is equal to the real part on the right. The imaginary part on the left is equal to the imaginary part on the right. So sometimes it'll allow you to solve some nasty looking equations. Okay. Fortunately, I don't think we'll have to worry too much about them. Okay, so doing some operations with complex numbers. And first we keep it easy. We just want to be able to add and subtract them. And it's fairly simple. If you've ever added or subtracted polynomials together, it's kind of the same deal. You just think in terms of adding like terms. So you're combining all the real stuff together and combining all the imaginary stuff together. So maybe an example is in order, right? So this is one you can do, right? So it's -2 plus 6x plus 4 minus x, right? If I want to rewrite that, I combine the numbers together, right? So -2 plus 4 is 2, and then 6 minus x is 5x. Okay, that's the same idea as what we're doing now. So now instead of the x thing, we just have this imaginary unit. So -2 plus 6i plus 4 minus i. So combine the real parts together, 4 minus 2 is 2, and then the imaginary parts, 6 i's minus 1 i's is 5 i's. Okay. And we always want to end in our standard form. So with the polynomial, you're conditioned to always writing that variable first, right? Now we want to keep that sort of quote-unquote variable second. Okay, but you shouldn't think of it as a variable. It's a number. Okay, let's look at another one. So example, here we have 7 minus -9 plus 2i. Okay, so, and then minus another imaginary number or complex number, 17 plus I. Okay, so here we have basically subtracting complex numbers, and to subtract them you have to, distribute the negative. So 7 plus 9 minus 2i, and then distribute the negative. minus 17 minus I. So combining all the real parts, you get 16 minus 17 is minus 1. And then all the imaginary parts, minus 3I. Looks like I screwed that up somewhere. Oh, I copied it wrong. All right, it's different than my problem, but I think it's right. 16 minus 17 is negative 1. Negative 2 minus 1, negative 2. I think that's right. Okay, so that's pretty simple. Multiplication, maybe a little harder. And then division a little harder still. So we're going to start with multiplication. And our example, we're going to look at this guy. So negative 8I times 2I minus 7. Okay, so it's kind of, again, it's a lot like what you did with variables. So if you have, well, we have to distribute, right? So anyways, negative 8 times 2 is negative 16. And then we have I times I, which is I squared. And then plus 56I, right? Okay, I squared we have from above, if you scroll back a little bit, I squared is equal to negative 1. Okay, so I can rewrite this expression to get rid of that I squared, which is what you want to do. Okay, so negative 16I squared, again, is negative 1, and then plus 56I. And we always want to end in the standard form. Right, so A plus BI. So here, negative 16 times 1, negative 1 is positive 16, and then plus 56I. Okay, standard form, good. Let's look at another one. Okay, so this time, both the real and imaginary parts are intact for both numbers. In that last problem, the 8I, you could simultaneously think of that as 0 minus 8I, right? The real part is 0. But without that, you could just do a distribution. This time, the real parts are non-zero, so we'll have to do a FOIL. Okay, that's what I'm getting at. Long story short, right? Okay. Right. So first, negative 24, outer plus 72I, inner plus 12I, and then last. Minus 36I times I is I squared. Okay, I need to get this in standard form. So what do I have? Negative 24, 72 plus 12 is 84I. And then minus 36 times I squared is negative 1. So negative 24 plus 84I plus 36. And then combine the real parts. 36 minus 24 is 12. And then plus 84I. Okay, so it's in standard form, and we're going to go. Let's do one more example. Okay, and this is this example is kind of leading somewhere. Okay? Negative 7 minus I, and then negative 7 plus I. Okay. Okay, so again, you're going to have to FOIL first. Negative 7, so 49. Outer, will be negative 7I. Inner, positive 7I. And then last, negative I times positive I is negative I squared. And something special happens, right? The I parts are all going to go away. I squared, we could replace it with negative 1. And we'll have 49 plus 1, which is 50. Okay. We'll do this when we in this next section when we work with division, and the process here is called multiplying by a conjugate. So it's kind of like if you remember getting rid of radicals, multiplying to get rid of a radical. It's a lot like that, okay, except here we're getting rid of the imaginary number. Okay, okay. So we just did multiplication. Here we're doing now division. Okay. And in order to pull off division, we need to work with the conjugate. Okay, so we work with conjugates. And the example above is basically multiplying two conjugates together. So if you're given something like, for example, negative radical 2 plus I, its conjugate is negative radical 2 minus I. Okay, so you just take the sign in the middle and turn it to the opposite sign, and that's the conjugate. Okay, so these guys turn out then to be conjugates. Okay, so what are we going to do with it? We're going to use the conjugates to do our division. Okay, so here's problem, I think it used to be number 22, but I'm just going to put example. Okay, these are all from the book. And so anyways, we have 3 divided by 4 plus I. Okay, so first off, these are both imaginary number, or complex numbers. It may not look like it, but 3 is the same as 3 plus 0i. Okay, so you're dividing 3 plus 0i by 4 plus I, and we want to put it in the standard form, a plus bi. Okay, so we can't leave it like this. So what do? I'm going to multiply top and bottom by the conjugate of the denominator. Okay, so if the bottom is 4 plus I multiply top and bottom by 4 minus I. Okay. In the numerator, I just have a distribution, so 12 minus 3i. And the denominator, I have a FOIL, right? So 16, the first, and then the outer, minus 4i, the inner, plus 4i, and then the last, minus I squared. Okay, got to simplify the denominator. So we'll have 16, 4i's are additive opposites, minus I squared is negative 1. Okay. I'll be a little careful with the negative negatives. That'll be a positive, right? So this will equal 12 minus 3i all over 16 plus 1 at the end of the day, which is 17. Okay, okay, it's still not in standard form. We're going to have to butterfly it. Okay, so you can do this with fractions. 12 over 17 minus 3 over 17i. Okay. Okay, and that's then finally in standard form. So you have to have it in standard form. I mean, what would be the point otherwise, right? Why are we even bothering? We already have something. I don't know. All right, so anyways, another example, used to be 28 in the book. 3 minus 4i divided by 4 plus 3i. Okay. So here I'm going to multiply top and bottom again by conjugates. So I have 4 minus 3i, and then 4 minus 3i. And I have some foiling. Okay, so on the top, the first 12, the outer minus 9i, the inner minus 16i, and then last plus 12i squared. I squared is negative 1. And then all over downstairs, FOIL that out, 16 minus 12i plus 12i, and then minus 9i squared. Okay. Then we're simplifying. Negative 12. 12 times negative 1 is negative 12. Negative 12 plus 12 is 0. But I have negative 9 minus 16i. Negative 9i minus 16i is negative 25i's. Downstairs, the 12i's are additive opposites. I have 16 minus 9i squared is the same as negative 1. So I have negative 25i. All over 16, that'll be plus 9, which is 25. And then you could simplify that. You know, negative 25 over 25 is negative 1. So you just get negative I. Okay. This is in standard form, believe it or not. If you don't see it, you can write it as 0 minus I. And then it's very clear it's in standard form. But this would be fine. Okay. I doubt the computer makes a big deal about it. Okay. So next thing we want to do a little bit of just work with negatives and roots. Okay. So section 4, we have roots of negatives. And generally when you are working with roots of negatives, you want to right off the bat convert it to an imaginary number. So if you have the square root of negative b, your first step should be to rewrite it as square root bi. If you don't, you could be in a little bit of trouble. Okay? And I think the book also, they write the i's in front of the radicals. Okay, that's fine too. If you're not putting that little hook on your radical, like I do, you see there's a little hook there, it's better to put the I in front. Okay? So in the book, they probably write their radicals like this, which I don't like. Okay. And in that case, it makes more sense to put the I in front. That way it doesn't accidentally look like, and I can't even stop doing the hook thing. If you put the I in front, you can't accidentally think the I is inside the radical. Okay, so that's why the book does it. I put it in the back, but if you put it in the back, make sure you're putting the little hook on your radicals so you know where the radical ends. Okay. Anyways, yeah, very important to do this because in particular, if you have, we can kind of look at an example, square root negative 25, so this is just a warning kind of example, times the square root of negative 4 versus doing it in this other way, negative 25 times the square root of negative 4. So the wrong way, let me get that out of the way, the wrong way is to use the root property, the product property of roots, and to multiply it out, right? Negative 25 times negative 4 like this. That would equal the square root of 100, which would equal 10. Okay, so what you want to do instead, this is dead wrong. Let me just put that in red. No, do not do this. Okay, no. Okay, so what do I do instead? Well, immediately, as soon as you get this situation, get rid of the i's. In other words, push the I out of the radical. Right, so you can rewrite this as square root 25i. And then this square root 4i, and then you can multiply stuff together. Okay, so square root 25 times square root 4 is a square root of 100, and then I have I squared. Square root of 100 is 10. I squared is negative 1, so you end up with negative 10. Okay, the other way you end up with positive 10, which is wrong. So just be careful. You know. It's just like in English, there's a right way to say some stuff and the wrong way, and sometimes you say it the wrong way, people have the wrong idea of what you mean, and it really just comes down to that, being able to communicate to other people what you mean. Okay, so let's go ahead and try a harder example then with this in mind. So we have the square root of negative 81 minus the square root of negative 144. So what you do first is get that imaginary unit to the outside of the radical. Okay. Get rid of the negative inside and push the I outside. Then you could simplify the radicals if possible. Square root of 81, sure, it's 9. Square root of 144 is 12. And then we can combine like terms, the imaginary parts. So 9 minus 12 minus 3 i's. Okay, let's keep going. Another example. So here we have negative 5 minus the square root of negative 9 squared. Okay, so this is a FOIL. You could rewrite it. At the same time, you might as well go ahead and push that I out the back door or out the front door, whichever place you want to put it. So you can put the I behind the radical or in front of the radical. Okay, so then minus radical 9i. Okay, we can simplify that even more. So it might as well, right? This will be minus 5 minus 3i, and then minus 5 minus 3i again. Okay, and then just FOIL. Negative 5 times negative 5 is 25 first. Outer negative 5 times negative 3 is plus 15i. Inner plus 15i. And then finally last plus 9i squared. So this will be 25 plus 30i plus 9 times negative 1. Okay. 25 minus 9 is 16. And then plus 30i will be our final answer in standard form. Okay. When we work with quadratics, sometimes you'll have, if the discriminant of the quadratic formula is negative, you're going to have issues, right? So I need to kind of prepare us for that direction, and this next problem does that. Okay. So we want to simplify negative 15 minus square root negative 18 all over 33. So it has that flavor, negative b plus or minus square root of b squared minus 4ac all over a, right? Okay, so I need to simplify this into standard form. So negative 15, so first I'm always pushing out that I, number 33. Then if you have any perfect squares, you can move those out of the radical. So 18 is same as 9 times 2, right? And then the square root of 9 is just 3, so you get 3 root 2i all over 33. And then you could simplify by butterflying. So this will be negative 15 over 33 minus 3 root 2 over 33i. And then you can simplify that. So the first guy, top and bottom, you can divide by 3. So you get negative 5/11ths. And again, for the second guy, you can divide top and bottom by 3. So you end up with 1 root 2 over 11, or just root 2 over 11i. Okay, so that's, then with that, let's go ahead and look at solving some quadratic equations. So solving quadratic equations where you have imaginary solutions, right? So example, x squared minus 2x plus 17 equals 0. And I want to solve that. And then my answer has to be in the standard form, okay? Okay, so again, it's a quadratic formula we need here. So a is whatever's in front of x, whatever's in front of x squared. So it's x squared, so there's a 1 there. We don't write it, but there it is. Okay. And then b is whatever's in front of x, and then c is what's, the constant, basically. Okay, so using the quadratic formula, x equals negative b, so negative negative 2 is 2, plus or minus square root of b squared, which is 4, minus 4 times a times c, all over 2 times a. Okay, so let's look at 17 times 4 is 8, bring up the 2, 4 for 68, and it'll be 4 minus 68 in the discriminant, so minus 64. Okay, so that'll be 2 plus or minus square root of negative 64 all over 2. Then, of course, march out the imaginary unit. So 2 plus or minus square root 64i all over 2. Okay. Finally then, well, there's more to come, but getting rid of the radical, we have 8i all over 2. And then we can butterfly it, so you get 2 over 2 plus or minus 8 over 2i. And then you can simplify. 2 over 2 is 1, plus or minus 8 over 2 is 4i. So 1 plus 4i or 1 minus 4i would be your solutions. Okay. Let's look at one more example, and then I think we'll call it quits. We have 2x squared plus 2x plus 3 is 0. Okay. And so it's A is 2, B is 2, C in this case is 3. So x is negative b plus or minus the square root of b squared, which is 4, minus 4 times a times c all over 2 times a. So we get negative 2 plus or minus the square root of 4 minus 24 will be negative 20 over 4. And then I can march out my imaginary unit, plus or minus square root of 20i over 4. Then I can simplify this radical. So radical 20 is the same as radical 4 times 5. And I could bring the 2 out of the radical. So 4 is the same as 2 squared. So you can bring a 2 out of that radical, leaving you with just 5 inside. I all over 4. Okay, and that I should be in the numerator. And then we could go ahead and butterfly it. So get negative 2 over 4 plus or minus 2 root 5 all over 4. And then we could simplify. So negative 1/2 plus or minus root 5 over 2. Great. Okay, so let's call it quits there. And thank you, as usual, for watching. And I will see you next time.